Hey everyone, how's it going? And today here we are on LeetCode again with another problem, that is maximum byte depth of binary tree. So we are given a binary tree and we need to find its maximum depth. For this case, its maximum depth is 3. So we will do DFS of the tree, and then we will keep on adding the depth. So for this particular value we will have a depth of 1, then we will go to its child, and we will add 1 to it, whatever the depth we have got previously, and then we will add 1 to it. And if we see that it's a leaf child, then we will compare it with the maximum depth that we have occurred till yet, and if it is greater than that, so then we will make it as the maximum depth, and then we will go again back to our previous node, and here the depth was 1, and then we go to the right child. Again we do the same process, and when we go here we will be having a depth as 3, and which is maximum than 2, that is the previous maximum depth, so it will, the maximum depth will become 3. And then we will move again here and do the same process, but here also we will see that the depth is 3, but 3 is not greater than 3, so the maximum depth will remain as 3, and then we will return the maximum depth as 3. So this is how we are going to proceed. We will keep on doing DFS and just comparing the depth with the current depth with the maximum depth. So first of all, we need a integer variable, that is max depth, and let us assign it as 1. Also, if root is let us see. So if root is itself null, so if root is equals to null, then there the depth is 0. So we'll return 0. Else the maximum depth becomes 1, and what we'll do is do a DFS from root with a current depth of 0, and and the maximum depth. Pass the maximum depth. Fine. Let us define our DFS function. We have three parameters. First is the root value. Then we have another integer that contains our current depth, and we have another integer that we will take as reference for the maximum depth we occurred till now while traversing our tree. So this is fine. If the root is null, then we'll return just return. Or if it is a leaf node, it means if both of its uh, child is null, then if root left is equals to null, and roots right is also equals to null. One more case, if here the value of depth plus 1 is greater than our max depth, then we will make our max depth as depth plus 1 and return. So if it is a leaf node, and then we will just compare whether it's a leaf node or not, and if it is, then we will compare the depth value occurred here with our max depth. So our max depth was 1 before, but when we occurred this leaf node, then it became then the depth was 2. So 2 is greater than 1, so that's why our max depth become 2, and then we return. Also, if it is not a leaf node, if it is a simple node, so what we are going to do is we will just do DFS in the both side, both child. We'll do the DFS for the both child. So first for left child with a depth plus one, and similarly for the right child also. So yeah, so once we are here, uh, this is not a leaf node. Then we will move to the child node for first for the left node with a depth value of depth plus one, which will be due to this node. And then again we will check whether it's a leaf node or not, and if it is, then we will compare, we'll add depth plus one, and then we will compare whether it's greater than our maximum depth or not, and if it is, then we will assign the depth plus one to max depth, and then we will return to previous node, and this function will be called, and then it will go to the right part with the depth plus one value, that is 2. Again we'll follow the same process, and this is how we will reach our solution. Let us run our code. Okay, we forgot to return here the maximum depth. Let us submit also. So if you like my solution, then please subscribe to my channel. Or if you have a better solution or suggestion for me, then please put it in comment box. Thank you for watching.